We're going to look at multiplying and dividing negatives with inequalities. And the first thing I've done is given you a example of negative x is greater than 3. And I've asked you to pick three numbers, any three numbers that x could be. Because x can be any number. I want you to pick me three numbers that x could be to sort of make that a possible solution. Ethan.
0, 1, 2.
Or would 0 work? Is negative 0? What's that?
Oh yeah, no, that won't work.
Okay, that won't work. But let's look at, Matty?
Negative 1.
Negative 1. So negative times negative 1 is what?
Negative times negative 1.
Yeah. So what's negative 1 times negative 1?
Negative 1, won't it?
What happens to the negatives?
Isn't it positive 1?
It's positive 1. So is positive 1 greater than 3? So that's the trap you can get. And I initially thought something very similar. So maybe try another number. Does it have to be positive or negative, our value? Let's start with that.
It has to be negative.
Has to be negative, doesn't it? So this value's got to be negative, x value's got to be negative. Liam? Negative 4. Negative 1 times negative 4 is? 4 is greater than? That works out. What do you reckon, Jean? Give me another number.
Also negative 5.
Negative 5. Dylan?
Negative 6.
Negative 6. We could go negative 3.1. We could go negative 1,000. Negative whatever it is, doesn't matter. Correct? As long as that value is less than. So you got to think in your head. What's that value got to be? Now don't verbalise it yet because we're going to practice rearranging and then use this as a skill, as a way to think back to our rule. So if I want to rearrange that, what do I need to do? Times both sides or divide both sides by negative 1. So I'm going to go negative x and I'm going to divide both sides by negative 1. What's that do to the negative sign on the left? Harry? Cancels out. So I'm left with x something negative 3. Now if we leave that exactly the same, I'm saying that x is greater than negative 3. Now I want you to think of a set of numbers that are greater than negative 3. Ryan, give me a number that's greater than negative 3.
Negative 4.
Is it greater than? Do you have more money if you owe someone $4 or if you owe someone $3?
Just 4.
So 4? Just 4? Okay. Give me another one.
5.
Another one?
6.
What about negative value? What's a negative value that's bigger than negative 3?
Negative 2.
Negative 2. How come none of those numbers feature up there?
Yeah.
I haven't flipped the sign. So we have to be very careful when we're multiplying or dividing. We need to flip our sign. Does that work now? Because x can be negative 3.01, x can be negative 4, x can be negative 5, x can be negative 6, x can be negative 1,000,000 for all I care. Does that make sense? So what's the rule? Could I have divided by negative, so could I have times by negative 1? Would that have worked as well when I was rearranging? So any time we are multiplying or dividing by a negative value with an inequality, what do we need to do? Pat?
Reverse the sign.
Reverse the inequality sign. Okay, so I'm going to get us to write that down now as our bubble rule. In a second, I'm going to get you to think about some things that I might see pretty regularly. So kids make mistakes, and we're learning stuff, and I want you to think about some mistakes that I might come across with in a second. So, anytime Now I'm going to get you to prove that this works. With another example. I'm going to show that this works using another technique. Because what are we doing with this? What are we trying to get with these equations? What's the skill we're using? Trying to get x by itself, or just called transposing. Now there are a couple of ways we can get x by itself here. So on the first example, I'm going to use our newly learnt technique. We're just going to use reverse BOMDAS. And then we're going to swap the negative sign at the end. So how do I attack that problem first? Dylan, what's the first thing I attack? The 3 or the negative 4?
The 3.
3? Add minus 3 to both sides, don't I? What am I left with on the left-hand side? Thanks, Connor. Negative 4x is greater than 12. What do I do now? Thanks, Pat.
I divide by negative 4.
Divide both sides by negative 4. And I'm left with x is less than negative 3. Very good. Now I could always shove that back into check. 3 minus, what's 4 times negative 3?
Negative 12.
Negative 12. So 15, it's got to be greater than negative 3. So we could put 4 in if you wanted. 3 times 3 plus 16 is?
19.
Is that greater than 15?
Yeah.
So that works out for us. Second method. Let's try and lower this down. Second method. What I'm going to do, and I'll do this in blue, is instead of following reverse BOMDAS, I'm going to take my 4x to the other side. How can I take 4x to the other side in my first line of working? Aaron, I can add 4x to both sides. Do I have to do anything with the inequality sign or not? Am I multiplying or dividing by a negative? So the inequality stays the same, and I'm left with 3 is greater than 15 plus 4x. What do I do with this now? It's a regular rearrangement from here. Take 15. And I'm left with negative 12 is greater than 4x. What do I do now? Pat? Divide both sides by 4. X is less than negative 3. Did I get the same answer? So if you are really, really concerned in an exam and you can't remember what you have to do with those negative inequalities, what should you do?
Put the x on the other side.
Yeah, you can add the x to both. You don't have to worry about it, do you? Cool. So a couple of methods that will help you get through, regardless of what the problem looks like. It's really, really important though that if you are going to multiply, divide with a negative indice, you remember that you change the inequality sign. Swap it around. Sweet? Any problem? All good.